Hello! This week we're going to go on and do some work on numbers. So we're going to look at fractions this week, and then next week we're going to go on and do percentages. So starters will be going over the work that we've been doing on brackets and factorising to keep your brain busy with those sort of things. And then, like I said, it'll be numerical work for the rest of the lesson. So, first of all, multiply out and simplify. Now remember, when we've got a bracket to multiply out, it's only the thing that's stuck to the bracket that needs to multiply the bracket. These two things don't belong to the bracket. So when we multiply out, we're going to do this, and then we've still got minus 12x and minus 3 on the end. Okay, so 2x times 3x is 6x squared, and then 2x times negative 5 is minus 10x. And then we collect like terms, so we can see that we've got 6x squared, but in x's, we've got minus 10x and minus 12x, so that's minus 22x, and then minus 3. Okay, that's that one done. Then for the second one, we'll do this one multiplying out two brackets. So remember, everything in the first bracket has to multiply everything in the second bracket. So this one we're going to do by splitting the first bracket, by breaking the first bracket and then multiplying out. Okay, so remember the way that we do that is we take the first term in the first bracket and we multiply that by the second bracket. And then we take the second term in the first bracket and we multiply that by the second bracket. Okay, so now we multiply these two brackets out separately. So x times 3x is 3x squared. X times negative 4 is minus 4x. That's that bracket done. Then we've got 1 times 3x, so that's plus 3x. And then 1 times negative 4 is minus 4. And then we see we need to simplify now by collecting like terms. So we've got 3x squared, and then if we have a look, we've got a minus 4x and a plus 3x. So that makes minus 1x altogether, and then a minus 4. And that's that one done. Okay, so the more you practice these, the easier they'll become, and the less you'll actually need to think about it. Okay, so what we're going to be going on to, the next section of work is this. At National 5, there are 3 units. There is expressions and formulae. There's relationships, and there's applications. And because we're not at school at the moment, we're kind of dotting about a bit with what we're doing. So we've done, our first section was expressions and formula, which we call E and F or EF. Relationships we just call R, and applications A. So if you see on something, for example, A1.4, it means it's applications, and it's basically section 4. Okay, so anyway, we're going to look at fractions to start with then, and we're going to concentrate today on mixed numbers and improper fractions. Okay, so we use mixed numbers and improper fractions for dealing with amounts that are bigger than 1. Okay, if you think about fractions that represent amounts that are less than 1, for example, 33 over 40, or 21 over 22, or 153 out of 155, etc. What these all have in common, if they represent less than a whole one, is that the numerator is smaller than the denominator. So it's been split into this many pieces, and we've chosen this many of them. So if you split something into 40 pieces and choose 33 of them, you've chosen less than the full amount, less than a whole one. Think about pizzas. Okay, split it into 22 pieces, choose 21 of them. You've got less than the whole pizza. So when we're dealing with amounts greater than 1 in fractions, there's 2 different ways of representing them. There's mixed numbers and improper fractions. Okay, so for example, a mixed number is where you get a whole number and a fraction. Okay, so like 3 7/8, for example, where you get a whole number and a fraction. An improper fraction is where the top is bigger than the bottom. Okay, so it doesn't matter whether the top is a lot bigger than the bottom or whether the top is a little bit bigger than the bottom. If you've got the case that the numerator, that's the top, is bigger than the denominator, that's the bottom, then you've got an improper fraction. Okay, and any mixed number can be written as an improper fraction, and the same the other way round. We can change any of these into the other form. Okay, always. So the first part of this we're going to look at is changing improper fractions into mixed numbers. Okay, so the first one is 37/10. I thought we'd stick with a nice easy number to start with. So if we've got 37/10, remember that every whole one has 10/10 in it. Okay, so one whole one is 10/10. Okay, so if we see how many tenths we've got 37. So if we look at how many tens are in 37, basically what we've got is we've got 10 tenths and another 10 tenths and another 10 tenths. There's 30 and 7. Okay, so there's our 37 tenths. Okay, so that's a whole one, that's a whole one, that's a whole one. So we've got 3 whole ones and 7 tenths left over. Okay, so that's not the easiest way to do it. It's not the quickest way, but we're going to do the next one like that as well, just to make sure we understand why the strategy that I'm going to show you works. Okay, so the next one. Remember, when we're dealing with halves, then a whole one is 2 halves. Okay, remember in a fraction, whenever the numerator and denominator match, that means a whole one. Okay, so our 9 halves, so we've got 2 halves, 2 halves, now we've got 4 halves altogether. Then we've got another 2 halves, that's 6 halves. Then that's 8 halves altogether, and we've still got another 1 to make 9 halves. So that's a whole one, that's a whole one, that's a whole one, and that's a whole one. So we've got 4 whole ones and 1 half left over. Okay, so basically what we're doing with these two examples that we've just looked at is we're seeing how many of that go into that. In other words, we're doing the top divided by the bottom. Okay, 37 divided by 10. If we go back to our primary school maths, rather than using any decimals, it's 3 remainder 7. Okay, so what that means is you've got 3 whole ones and 7 tenths as well. Okay, in the second one, you would do top divided by bottom. So 9 divided by 2 is 4, remainder 1. So that means 4 and 1 half. Okay, so the denominator doesn't change when we change from improper fractions into mixed numbers. So basically what we're doing is top divided by bottom is equal to a number and a remainder. Okay, so our fraction then, when we change it into a mixed number, the number is the big number there, the remainder goes on the top of the fraction, and the bottom of the fraction I'm going to just say bottom. It doesn't change. Okay, so in this next example, we do 15 divided by 7 is 1. There's 1 7 in 15. Oh, 2. Silly me. There's 2 7s in 15. So we say that that's 2. We've got 1 left over. So that makes 1 and then a 7 on the bottom. Okay. So remember, 1 is the remainder, the bottom doesn't change, and the number answer is the big number at the front. Okay, so the next one, 23 divided by 8. When we work that out, 2 8s are 16, 3 8s are 24, so we've only got 2 whole 8s there, and the remainder in 23, when we've taken out 16, is 7, so it's 2 and 7/8, okay, because 23 divided by 8 is 2 remainder 7, okay. So they're not always as straightforward as that. Sometimes you need to do a little bit of working out. So when we've got 463 divided by 3, we might have to do an actual divide. So 3 into 4 goes 1, carry the 1, 3 into 16 goes 5 times, remainder 1, and 3 into 13 goes 4 times, remainder 1. So the answer to this one is 154 and 1/3, because the remainder goes on the top. Okay, same sort of idea here. We're doing top divided by bottom. So 138 divided by 5. 5 into 13 goes twice, remainder 3. 5 into 38 goes 7 times, also remainder 3. So the answer here is 27 and 3/5. Okay, so we've only done a few examples, but I don't think we really need to do any more of that. So basically, stick with this, that it's top divided by bottom, and that'll give you a number and a remainder, and that's how you write it as a mixed number. So the number is your big number, the remainder goes on the top, and the bottom stays as it is. Okay, then when we're going the other way round, changing mixed numbers into improper fractions. So it's the same as what we just looked at, in that the denominator doesn't change, okay? So when we change this 4 2/3 into an improper fraction, it's going to be 3 on the bottom, okay, in the denominator. So what we need to look at is, in these 4 whole ones, how many thirds have we got? Well, we know that there are 3/3 in every whole one, and we've got 4 lots of that. So we're going to do 4 times 3 is 12. So we've got 12 thirds here and another 2 thirds there. So that gives us 14 thirds altogether. Okay, looking at the next one. We've got 6 whole ones and a fifth. So our answer is going to be in fifths, because the denominator doesn't change. In our 6 whole ones, remember, in every 1 whole one, we've got 5/5. So if we've got 6 whole ones, we've got 6 times 5, which is 30/5. So we've got 30 and an extra 1, so that's 31. And you can see that what we're doing here is, each time we're keeping the denominator the same. Then to get the number on the top, what we do is multiply the whole number by the denominator, and then add the number that's on the top. Okay, so we would do 20 times 9. So remember, 2 9s are 18, so 20 times 9 is 180. Add the 3, makes 183. Okay, this one, we're going to do 10 times 8, and then add 9, and we're going to keep the 10 on the bottom. So 10 8s are 80, add the 9, makes 89. And then the last one, same process, 4 times 7, add 3 is going to go on the top, and 4 is going on the bottom, because it doesn't change. So 4 7s are 28, add 3, makes 31. Okay, so that's all we're going to do today. I know that will be absolutely revision for most of you, but then if it's a while since you've done fractions, you maybe needed a bit of a refresher. So I'll give you some practice questions to do. Give me a shout if there's any of it that you're really not sure about, and tomorrow we're going to go on with our next bit of fractions. Okay, see you then.